Hello, hello students. Are you audible? Hello, hello,
Yes, sir.
hello.
Yes, sir.
Hello. Hello, hello, students.
Yes, sir.
Are you audible?
Yes, sir.
Hello, hello,
Yes,
Yes,
sir.
sir.
students. Are you audible? Yes.
Yes, yes, sir.
Can I start? And I'm going to start.
স্যার অনেকে ক্লাসে জয়েন হতে পারছে না, জয়েন করতে বললো স্যার।
Hello. Hello, students. Are you audible? Hello.
Yes, sir.
Yes, sir, you're audible.
এবার এবার শুনতে পাচ্ছো? হ্যালো।
হ্যাঁ, স্যার।
হ্যাঁ স্যার,
Audible?
এবার শোনা যাচ্ছে। ইয়েস স্যার, ইয়েস স্যার।
হ্যালো।
হ্যালো স্যার।
হ্যালো।
স্যার, আপনার কথা শোনা যাচ্ছে।
নমস্কার, কোভিড-19 আনলকের প্রক্রিয়া এখন সারা বিশ্বে শুরু হয়ে গেছে। এই সময় নিজের
হ্যাঁ হচ্ছে। So I am going for the start with the new again. Biological activity and a relationship between the structure of the compound. So why I am going for the SAR? Because whenever you are going to write any structural activity relationship, some of the important points, one by one I will clarify it. And this time we are having this type of relationship between the structure of the compound and your biological activity. So new tool is available, that is computer drug design. It is a three-dimensional concept. With the help of computer drug design, you can easily detect the correlation between the molecules and the chemical structure and so let us start with the computer drug design CDD, by which you can rectify the existing compound. For example, penicillin is one of the penicillin G is one of the primitive antibiotic, but from there you can get the basic moiety is there. It is thiazolidine ring along with one beta lactam is there, but you have to modify it and you can get better compounds, semi-synthetic compounds like ampicillin, amoxicillin, carboxylin, all these are there. So existing compounds can be modified and put for better activity. What are the side effects is also one of the factors. You have to see the side effect. The new molecules should not have this type of side effect, and it should be better than previous one. So this time we have to take the help of CDD, computer design, and you have to evaluate by SAR. Now, how to write? How to write SAR, structural activity relationship can be right. So it is a powerful techniques for analysis by seeing the analysis of toxicological properties, and also you have to see the carcinogenicity and cardiotoxicity. So how to write SAR? It is very important. While writing, you have to first see the basic moiety of the molecules. What is basic moiety? Basic moiety is that where you can see the lead compound. What is lead compound or pharmacophore? That is, it is the basic unit of a molecule, of drug molecules or any type of molecules, which is essential. Without this basic moiety, the drug becomes inactive and there is no question of going SR. So you have to find out the lead compound or pharmacophore of the molecule. So what is lead compound? I am telling that is the basic moiety which is needed for the to development of the new compound. But at Second times, you have to see the position, numbering of the position. So before writing for SAR, at first you draw the structure of the molecules and find out the basic moiety of the molecules, that is lead compound or pharmacophore of the molecule, which is essential for the activity of the compound. And then you have to go for a numbering, position 1, 2, 3, 4, like this. And after that, you have to go for substituents, whether it is substituents R1, R2 is there. That is numbering is needed. And after numbering, you can substitute. You can substitute these molecules, the numbering, that is these groups, with one group to another, and time to time you have to abolish or omit some of the groups and replace by new groups, by which you can get better compound and more active compound, and it is less toxic. For example, I am giving you an example of chlorothiazide. Already you have studied chlorothiazide. It is a diuretic, but when you the 4 and 3 and 4 position, one double bond is replaced, is dehydrogenated, then you will get hydrochlorothiazide, which is very potent drug. It is 100 times more powerful than that of the chlorothiazide, with less side effect. So there is increase of the activity. So increase of the biological activity is increased by changing the group. So this is the process of writing SAR. And after writing, find out the relationship. What are the relationship between chemical structure and the 3D structure? So if you go for the chemical structure in 3D dimensional, then you can place in either in the 3D, in the front position or in the back side of the molecule, you will get different activity. So 3D dimensional figure should be considered. Rational drug design, RDD, is one of the process for this type of activity. Computer drug designing, rational activity, by using computer, you can get 3-dimensional concept, and you can change that, enable the determination of the chemical groups. What are the groups? Is the target for biological activity, and at this time you can get a relationship with this structure. Now I am going for the structural activity relationship of your some of the compounds. That is already I have discussed. Again, I am going to repeat this. Structural activity relationship 1,4-dihydropyridines is very important. Antihypertensive drug. Example is nifedipine, amlodipine, and felodipine. And this is the basic moiety of the molecules is 1,4-dihydropyridine. That is, if you see the structure of pyridine, then dihydro means 1 and 4th position is dihydro hydrogen molecules is there, and it is dihydrogenated. And this is the example of this nifedipine, felodipine, all these are there. And I will go again repeat it, how to perform this 1,4-dihydropyridine. Next, I am to go for SAR of ACE inhibitors, angiotensin converting enzyme inhibitors, that is enalapril, lisinopril, and captopril. These are the drugs that we can use for the treatment of hypertension, and it is an angiotensin inhibitors, which is angiotensin is secreted from the kidney, and from there renin, and it is inhibitors. It is indirectly, it is act as antihypertensive drugs. It has got some drawbacks. And enalapril, lisinopril, captopril, all as the previously used, nowadays it is not at all used because it causes some uh, cough and all the time cold. The cough is there and edema is there, angioedema is there. Because the angiotensin inhibitor, it is edema may cause it. Now, the best quality of drug is that 2 antagonists, which is a losartan and telmisartan. It is my another category of drugs I'll discuss today also. Next is the chlorothiazides or benzthiazides or hydrochlorothiazides. This is an thiazide diuretics. I'll discuss today also. And SAR of carbonic anhydrase inhibitors. So first of all, I am going for the 1,4-dihydropyridine. So you see this is the structure of 1,4-dihydropyridine. And in one position, you see one in one position of the pyridine, NH is there. This N1 hydrogen is when replaced with any substituents, then there will be decrease, that the molecules become inactive. So the 1,4-dihydropyridine is the basic pharmacophore, and when you replace this one hydrogen in one hydrogen, and it is the molecules becomes inactive. So you have to place molecular substituent of N1 is not there. Next is number 2 and 3. 2, 3 position, we are having methyl groups. Methyl groups is there. In both sides, we are having methyl groups. And if both are methyl groups, it is also some activity will be there. But if you increase the methyl instead of methyl group, in case of amlodipine, if big molecules present in one of the position of 2 position of the molecules, then you will get better compound. That is, previously it was nifedipine, but now it is amlodipine. And amlodipine is also good quality of drugs. So 1,4-dihydropyridine is the basic moiety, and you 2 and 3, 2 and 6 position. Every time we are having methyl groups. And if we change the methyl groups in one of the position, 2 position of the molecules, we will get better compound like amlodipine, and it is a very good antihypertensive drug. And now you go for the 5 and 6 position. It is one, what is type of the T? It is an ester, COR. COR, it is a ester group is there. Ester group in the 4 and 5 position, 3 and 5 and 6 position. And these 5, 6 position, if you replace this ester group, and optimum activity decreases. That is, if you ester group optimum activity, if you increase one nitro group in ester group addition, then it will be decreased. So you see 4 position is another reason, that is a very important position of the 1,4-dihydropyridine. It is an cycloalkyl group. If you add one benzene ring is there, and this benzene is very, and if you add benzene any polar group or any cycloalkyl group, then there will be decrease of the activity. Benzene ring is also substituted with nitrogen, NO2, that is nitro group. In case of nifedipine, it is nitro group. So in ortho position, the nitro group is important time to time. In case of felodipine, chlorine groups are there, both chlorine groups are there. So the benzene ring is very important in 4 position, and this benzene should be substituted in ortho para direction. If you substitute it in the meta position of these benzene molecules, then the activity will decrease. So you see, I am giving you some important points. That is, the 10 points is there for the structural activity relationship of 1,4-dihydropyridine. First of all, this 1,4-dihydropyridine ring is essential for activity. And number 2, if the unsaturation of the basic ring is there, then the activity, the molecules becomes inactive, that is decrease the activity. So unsaturation of the basic ring, that is pyridine. If unsaturation is there, unsaturation is in the 1 and 4 position. But if its unsaturation position is all the other positions, 3, 2, inactive. So the basic moiety 1,4-dihydropyridine is essential, and another point is that the unsaturation of the basic moiety of the pyridine or decreased activity. Now I am telling you that any one position is, if you oxidize, if you replace some of the groups, that is, if you oxidize the pyridine by pyridine, or you can reduce pyridine, only pyridine, then the activity will reduce. This total activity will be reduced. 2 and 6 position, I am telling you, it is alkyl, or you can also amine groups is tolerated. But if you add other groups in 2 and 6 position, that is, if it is alkyl, that is, if you use methyl, okay. But if it is ethyl, larger group, then it will be decreased. But if you add amine groups, then it can be also having some activity. Now C3 and C5 position is very important for activity, because here with some electromutant groups, that is there, that is, if it is removal of the CO group, carbomethyl group, or CN group, it reduces activity. Example is estradipine. In estradipine, it is shows an agonistic activity. Antagonistic activity is not there. So agonistic activity, that is, it is opposite activity will be there. So antagonistic activity will decrease, and it shows some agonistic activity if you remove this electron withdrawing group in the C3 and C5 position. Now, substitution is also important. Larger groups of ester greatly you can even increases, and activities bulk tolerance is that amylodipine. In amylodipine, you see C3 is methyl and C5 is ethyl. So this time you will get better compound by changing C3 and C5 position. C4 carbon becomes when C3 and C5 is not identical. So when C5 and C3 is not identical, this is very important, because if they are same, there is no question of chirality. If C3 is methyl, C5 is methyl, in case of nifedipine, it is no problem. There is no chiral activity is not there. There is no question of stereoisomeric substances. But if you change C3 is methyl and C5 is another group. Then the C4 carbon becomes chiral, and you can get the enantiomers, that is selectomer enantiomers, that is S isomer is very active, minus isomer is very active. So this time, so chirality of the 4 is very important because of the, if you change the groups and time to time some compound like nicardipine, it is also chirality, it is different and you get better compound. I am telling in the before, that is the 4th position is very important because 4th position is benzene or phenyl ring is there, and if you substitute this alkyl or cycloalkyl groups, then there will be decrease, and substituted I give you it is ortho direct ortho nitro group, or if it is there, and if you change this ortho para direction substitution is give some electronic activity and you will get some activity. So para substitution also have some effect. Next, I am giving you the structure of nifedipine. This is nitro group is there, 2,3-methyl group is there, and also ester group is the 5 and 6 position, and 4 is the phenyl ring, benzene ring is attached with nitrogen. It is one of the primitive type of antihypertensive drugs, and the basic moiety is 1,4-dihydropyridine. So 1,4-dihydropyridine is a basic moiety. And the example of this, some of the drugs, some of the drugs is nifedipine, and diltiazem also another category which is benzthiazide derivative, and verapamil is cycloalkyl derivative. These are the example of some antihypertensive drugs. Now I am going for the SAR of AC inhibitors like captopril, enalapril, and lisinopril. Here you see that all the structure having this type of pyrrolidine. Pyrrolidine, that is COH group is attached with pyrrolidine. So pyrrolidine is the basic moiety of the molecules. So if you see the gel structure of the molecules, then you see one benz part, this ring is there, benzene ring is there. This benzene, this is an pyrrolidine ring, and it is R1 and R2, and it is an compound name is, if it is R1 is methyl group, R2 is ethyl group, and it is, if it is pyrrolidine ring along with the acid in the first position, the second position, this is enalapril, and in case of enalapril, and if you see, now you see the structure, there is ring is ring is there, R1 R2 2 substituent is there, and one benzene is attached with it along with the one ethyl group attached. So you see the structure of this basic moiety, and if you go for the SAR, ring is there. What types of ring is there? The ring is, I am telling it is an pyrrolidine ring, and one methyl group is resemble. The chain is like alanine, and one butyl group is there in R2, R1, and groups of binding with zinc is a benzene group, and it is one sulfonyl group as you can attach with this, and leads to shorter duration of action. But if you increase the better compound, so it will be, if R1 is butyl, and you will get orally active compound. So this is the basic structure of the enalapril molecules, And what the ring, pyrrolidine ring is the basic moiety, and this pyrrolidine ring is attached with the bonding of the methyl groups and butyl groups, and one another group is there. R is what R stands for? R stands for the. So this time I am going for another category of drugs. That is, this is the structure of captopril, synthesis of captopril. You see, it is pyrrolidine 2-carboxylic acid is attached, and this is the basic moiety. And this basic moiety, when treated with your methyl propionic acid and 2-methyl chloropropionic acid.
হ্যালো
हाँ बोलो।
হ্যাঁ স্যারকে দেখিয়েছি আমার বেরোচ্ছে
अच्छा ठीक है।
অনেকে অনেক
This time to go for the structural activity relationship of another category of drugs, that is angiotensin. Angiotensin 2 inhibitors it is oh baba, internet it is one type of substituent, that is imidazolidine ring is there, and this imidazolidine ring is attached with some activity is there, and this imidazolidine the basic moiety of the molecules, and this can be changed. If you see the structure of losartan, it is one of the compound. You see an imidazole ring is there, and this imidazole ring is attached with a bulky tetrazole molecules. Tetrazole molecule is there, the bulky group is there, and so who is the pharmacology of this compound? It is imidazole, methyl imidazole. This is a very basic compound, basic moiety, and you can change substituent, bigger substituent, you can get better compound. So I am giving you some important points like this. Methyl dopa you have already synthesized. I have already given you the procedure of synthesis of methyl dopa. It is an antihypertensive drug, and very important antihypertensive. Still now it is used because it is the only one choice of drug for the treatment of hypertension in case of those who are suffering from that is in case of this is very important, those who are carrying babies, that is this time at a gestational period only this drug is applicable for hypertension. No other drug is suitable, and this is one of the till now it is dopamine type of drug, and this is very important drugs which is in place. Next I am going for the SAR of thiazide diuretics, that is example is chlorothiazide, hydrochlorothiazide, benz chlorothiazide. These thiazide derivatives I am giving you the SAR. Already I have discussed. Till then it is very important in the point of view of your exam. So this time you see the structure of these thiazides. This is a benz thiazide. So in one position sulfoxide group is there, yes, SO, and 1 and 2 position there is double bond. Numeric is that is N is there, another nitrogen is there, and it is azides, and the benz azides means sulfur, and the 2 azides are there, nitrogen are there. In 3 position it is substituent are there, and in between 3 and 4 position there is one double bond, and in along with this one benzene ring is with this, and in the 7th position and sulfonamide groups is there, and R1 it is in the 6th position. So while doing SAR of this type of compound, you have to note down some of the important points. That is, in one position, you see sulfoxide group is there. And this sulfoxide group, if you want to change these sulfoxide groups by another type of oxygen or any type of carbon, in presence of sulfur other than carbon, or you can change nitrogen, activity will be reduced. So in one position, sulfur or sulfoxide group is very much important. And this time, if you change this sulfur instead of nitrogen and oxygen or carbon, then there will be decrease of the activity, but more or less activity will be there. Now consider in the case of position 2. Position 2, you are seeing that one nitrogen is there and 1 and 2 that double bond is there. If you, this nitrogen is basically, and if you add an electron within group in the nitrogen, then sulfoxide group is itself is a very electronegative. And whenever you introduce another electronegative group to the 2 position, then what will happen? Then if you change this, then there will be alkyl group can be tolerated. If you but if you group another types of groups, bulky groups, then there will be the electron within capacity of sulfoxide will decrease, and ultimately molecules will become less active. So you can only replace hydrogen or you can replace methyl group. Other than if you want to increase, if you give another type of bulky groups or electronegativity be reduced, then there will be electron weighted group will be there reduced of the sulfoxide group and ultimately it becomes inactive. Now in case of 3 position, you see 3 position is also very important, because in the substituent of the 3 position, if you include CH2Cl or if you increase CH2C6H5, or you can use C2CH2 CH2CH2C6H5, then there will be the activity will be there, but this activity of this soluritic activity, that is salty nature of the molecules, increase. That is, it can eliminate salt from the body. There is soluritic increase. So in the 3 position, add CH2Cl, CH2CH2C6H5, or any type of other groups are there, then there will be increase the salt uritic activity. The soluritic activity will increase and the molecules becomes very much active. Now you see in the 3 and 4 position there is one double bond. This is a very vital, because in case of chlorothiazide, the double bond is there, but if thiazide, the double bond becomes not there, and then N becomes NH, and it is called a hydrochlorothiazide, which is very potent drug than chlorothiazide. So it is 100 times more potent than that of hydrochlorothiazide. So chlorothiazide and hydrochlorothiazide example of the saturation of the double bond in between 3 and 4 position. Now, in case of 5 position, and if you increase 5, 4 and 8 position, 5 substituent. In case of 4, you are only having saturation with hydrogen. But if you add 5, 8 and 4 position with higher groups, alkyl groups, methyl groups, or any other groups, then what will happen? That is, there will be molecules becomes active, inactive, and all the diuretic activity of the molecules will be abolished. Now, sixth position, I am telling it is very important because sixth position we are in case of chlorothiazide. We are using chlorothiazide, that is chlorine. Chlorine molecules should be there. Chlorine molecules will be there in the sixth position, and molecules is very much essential. And if you change this with the bromine or chlorine, CF2, difluorochloro, then that is, it is also more potent. But one thing you have to remember, the seventh position is very important because here you see sulfonamide, sulfonamide group is there, SO2NH2 group. This SO2NH2 group is essential. If you add any other groups in the seventh position, the molecule becomes inactive. So sulfonamide groups is very important for the activity of the thiazide diuretics, and this is the SAR of this. So this thiazide derivative has got some improvement by changing the position of the molecules, especially in 7th position, sulfonamide must be there. In R1 position, you can add chlorine or chlorine CF3, chlorine difluorocarbon, that is difluoride, and you can change this only thiazide. If hydrogen is there, R1, R is hydrogen, it is only thiazide, that is, it is very inactive. And so by you can get better compound of thiazide by changing this position at 7, 6, 4 and 3 saturation and some substituent. Next I am going for the synthesis of chlorothiazide. Already I have discussed. It is with chloroaniline, chloroaniline, it is chlorophenic acid, and then you can get a compound, and after treatment with acetic acid, you can get chlorothiazide included in your syllabus. So chlorothiazide is only chlorine is in the 6th position, 7th position is sulfonamide group, and in 3 and 4 position there is unsaturation division. Now, if you change, I'm telling you hydrochlorothiazide, it is R1 equal to H and R2 equal to Cl. This is a very good quality of drugs. And in 4th position, there is saturation is there. And the type fluoromethazide is also another category, H2Cl in the 3 position. And methichlorothiazide, R1 in the 3 position, H2Cl. Hydrofluorothiazide, CF3 is there. So now I am going for another SAR, that is acetazolamide. It is a carbonic anhydride inhibitor. It is also one of the diuretics, which is widely used for the treatment of diuretic activity, as well as it is used for the treatment of glaucoma. It is one of the disease which is due to intraocular pressure increase, and so many drugs that we may still now. Acetazolamide is used to reduce the intraocular pressure, and also it is the as diuretic. So you see here the basic point is sulfonamide group, SO2 and H2 groups. That is acetazolamide. That is, it is an azole, thiazole derivatives, and this thiazole derivative is a heterocyclic in nature. And these sulfonamides is, if you substitute these sulfonamides N with H, any then if it is activity will be remain same. That is, if it is one group, one hydrogen is replaced by methyl group, that is methyzolamide, then you can get activity. But whenever both the 2 hydrogen is replaced by other compound, then the molecules becomes inactive. So the methyl group at end position remains active, but whenever you replace these both hydrogen of amines, sulfonamide amine NH2, then it will become inactive. Only one substituent is desirable in case of methazolamide, and this is a very important drug for similar drug like acetazolamide. Next is you have seen one. I'm telling one heterocyclic ring is there. Thiazole ring is there. Thiazole ring is attached with it, and this azole thiazole is as some aromaticity is needed. If it is not aromatic, then there will be no activity. So the heterocyclic moiety, which is attached with sulfonamide moiety, it is very important because if aromaticity, if you add benzene, there is some benzolamide, some benzene cut drugs are there. This is also having some activity less because benzene has a heterocyclic aromaticity more than that of the benzene. And you see these SAR of the acetazolamide, and it is one of the drug as act as diuretic. Now synthesis of diuretic acetazolamide is from hydrazine. Already I have discussed in the class of diuretics. So it is first of all you treat it with treat this hydrazine with amino thiocyanate. Upon closure of the ring and on acylation, you will get amides, and then these amides on treatment with a silver chloride, you will get derivatives, and acetazolamide you will get on amination. Amination is needed for this is the basic synthesis of. Next I am going for the sulfonylurea. It is one of the drugs for the treatment of diabetes. So diabetes already I have studied, and now I am going for the SAR of sulfonylurea drugs. So what is the basic moiety? Basic moiety of sulfonamides is one sulfonyl group is there, and it is some one position and R1 and another is R2. So it is a sulfonylureas. So urea is CONH2, and here you CONH2, one part is attached with R2 and one part is to SO2 R1. So in R1 and R2 are the very important position of the sulfonylurea, and you must have some that is R1 ring should be it must be lipophilic. R1 must be lipophilic in nature so that it can penetrate the blood-brain barrier. Lipid solubility increases and it can penetrate inside the cell, and must have an aromatic ring, and that is aromatic ring. That is you are seeing in the sulfonylurea structure. You have the structure of the molecules, that is tolubutamide and chloropropamide, tolazamide and acetohexamide. You see one benzene ring is there, that is one toluene attached with sulfonamide group, sulfonylurea group. This is tolubutamide, it is the basic, and chloropropamide, one chlorine is in the para position, that is fourth position of the benzene ring, and one sulfonylurea is there. This is the first generation of the hypoglycemic drugs, anti-diabetic drugs. And next you see aromaticity, that is one aromatic compound. John Levy. Next is in the para position you see of the benzene ring. It is chloro, bromo, and you can also try chloromethyl. So all the add hyperglycemic activity, if you want to increase, then the para position is very vital, because if you add methyl group, amino group, and acetyl group, fluoro group, bromo group, or methyl thio group, or thiomethyl group, it enhances the activity. The larger the more groups, if it's a larger groups, in case of glipizide, glavencalamide, glyburide, glycazide, all are belongs to the, if this R1 position is a bulky group, that is ethyl group is attached down of then, and it is the second generation of the drugs, it will be there, which help to bind with the receptor. So the R1 position, the benzene will be must be there, and benzene is in the para position. There is substituent will be there, and the second generation of the drugs is invented due to the addition of the ethyl carboxamide groups in case of glavencalamide, glybizide, glycazide, all categories of drugs, second generation of anti-diabetic drugs can be available. Now, in the case of R2, that is in the urea position, that is sulfonyl urea position. So, if you increase the N is substituted with a bulky group, and if you increase the N-methyl group, N-ethyl group, it is inactive. And if you become low active, but if you increase N-dodecyl above, it will become inactive. So that the addition N-methylation will give some activity. N-propyl or N-hexyl is the more potent. In case of chloropropamide, this R2 is propyl group, and in case of N, if it is hexyl group, it is a very potent drug. So, in case of sulfonyl urea, if you see the structure of the molecules by changing R1 and R2, you can get different types of compounds, and the changing of the activity you can get by changing R1, you can increase the lipophilicity, and you can also R2 is be replaced with some higher groups, the propyl groups or hexyl N-hexyl groups, it will be more potent. But if you add methyl group only, carbutamide, in case of carbutamide, it is methyl group, it is very obsolete drug. It is not at all used nowadays. So these are the SAR of your sulfonylurea category of drugs. And next category of drugs, I am going benzoic acid derivatives. Already I have discussed in previous class. In benzoic acid, that is a local anesthetic. Already your hemostasis sir has discussed. Until now, I am going to give a brief account. In this benzoic acid derivatives local anesthetic, it has three parts. Lipophilic part, that is benzene ring. In case of lidocaine, it is xylene, and in one hydrophobic part is there, it is generally tertiary amines, and tertiary amines is for the proton acceptor of the molecules, and the intermediate bonds is H star bond is there, amide linkage, which is very much essential for the local anesthetic activity. So today, this much, I want to stop this. Thank you all for my Zoom class. Okay. If any queries, you can ask me. Uh, the PPT in the Zoom class. Okay. Thank you.